True peace, Ken's legged, wheeled, and tracked robots could be on same power curve. Find U.S. Army researchers, man, peep the slang. A new formula from Army scientists is leading to new insights on how to build an energy efficient leg teammate for dismounted war fighters. Man, peep the slang. In a recent peer reviewed PLOSE1 paper, the U.S. Army Combat Capabilities Development Command, known as DEVCOM, Army Research Laboratories, Alexander Cott, Sean Gart, and Jason Pussey offered new insights on how to build autonomous leg robots that operate as efficiently as any other ground mobile systems it used could lead to potentially important changes to Army vehicle development. Scientists said they may not know exactly why leg, wheeled, and track systems fit the same curve yet, but they are convinced their findings drive further inquiry. Peep the slang. If vehicle developers find a certain design will require more power than is currently possible given a variety of real world constraints, the new formula could point to specific needs for improved power transmission and generation, or to rethink the mass and speed requirements of the vehicle, Gar said. Inspired by a 1980s and formula that showed relationships between the mass, speed, and power expenditure of animals, the team developed a new formula that applied to a very broad range of leg, wheeled, and track systems, such as motor vehicles and mobile robots. Although much of the data has been available for 30 years, the team said it is the first to actually assemble it and study the relationships that emerged from this data. The findings show that leg systems are as efficient as wheeled and track platforms. In the world of unmanned combat area vehicle and intelligent munitions, there is a growing role for dismounted infantry that can advance, often for multiple days, and attack in the most cluttered terrain, such as mountains, dense forests, and urban environments, said Koch, who serves as the laboratory's chief scientist. That's because such terrain provides the greatest cover and concealment against the unmanned aerial vehicles. Man, peep the slang. That in turn demands the dismounted infantry should be assisted by vehicles capable of moving easily in such a broken terrain, he added. Leg vehicles possible, autonomous, would be very helpful. Peep the slang, saving energy for soldiers. One of the problems with leg robots, Koch said, is they seem to have poor energy efficiency, which limits teaming with soldiers in austere battlefields. For the past 30 years, U.S. military scientists have addressed a number of challenges of developing autonomous vehicles, said Koch. Ground vehicles that maneuver on wheels or tracks, and air vehicles that resemble small airplanes, which we call fixed wing, and small helicopters, which are rotary wing, are now quieter and easier to integrate in troop formations, but for leg platforms, many hurdles remain elusive, and a huge one is making them energy efficient. Peep the slang. Soldiers cannot afford to carry fuel or batteries for energy thirsty leg robots, he said. The paper explores whether artificial ground mobile systems exhibit a consistent trend among mass, power, and speed. As a starting point, the team investigated a scaling formula proposed in the 1980s for estimating the mechanical power expended by an animal of a given mass to move at a given speed. It compared this with a wide range of systems varying in size, weight, and power that are autonomous or driven by humans. The team found the answer to their research question. A similar, consistent relationship does, in fact, apply also to ground mobile systems, including vehicles of different types over a broad range of their masses. Man, Peter Slang. Koch said this relationship surprisingly turned out to be essentially the same for leg, wheeled, and track systems. These findings suggest that human-made leg platforms should be as efficient as wheeled and tracked platforms, he said. To conduct this study, the researchers collected diverse ground mobile system data from a literature review of previous studies and published data sets. They studied wide ranges of sizes and morphologies within a data set that included, for example, a 17th century British cannon, the Ford Model T, the M1 Abrams tank, and a ACELA train. Man, peep the slang. Symbols, I guess. It's a graph. And people slang determining design trade-off. Guar said the research is relevant to designing ground mobile systems because it helped designers determine trade-offs among power, speed, and mass for future terrestrial robots for defense applications. One Army goal is to develop new types of autonomous or partly autonomous ground vehicles to develop supplies to soldiers in challenging terrains, he said. To haul supplies, it must be able to carry a certain weight or mass at a certain time or speed, Guard said. The formula can approximately the amount of power the vehicle would need, researchers said. The Army must develop feasible yet ambiguous targets for trade-offs among the power, speed, and mass of future terrestrial robots, Scott said. It is undesirable to base such targets on current experience because military hardware is often developed and used for multiple years and even decades. Peep the slang. Therefore, the specifier and designers of such hardware must base their targets, competitive yet achievable, on future technological opportunities not necessarily fully understood at the time of design, he said. The formula developed in this paper gives such a target and could enable the Army to make predictions of future performance of ground platforms such as leg robots given design constraints like vehicle and motor weight and desired speed. Said caught. Okay. Yeah, keep the swing. Let's watch the video. Keep the slang.